Hello, Chuck Boutall here, Director of Education, and it's time for another When It Comes Down to It. This time we're talking about permeance. Basically, permeance factor in a material is determined by the ability of a vapor or a liquid to move through a semi-solid or porous type solid material. Basically, what this means in our industries, we're talking about water vapor transmission and how easily it can move through different building materials. This has a great deal involved with your drying times, because when the perms are low, the water moves slow, which means that it will take longer to dry that item. When the perms are high, the water will fly, so that means your drying times are going to be shorter or faster. The thing to remember always is permeance is like the speed limit of water through a building material. Now, there's actually a definition of permeance and how to figure it out, and that is you're going to take the permeance factor of the material, which can be found in some cases in the Munter's Dehumidification Handbook. This is a free download offline if you'd like to do that, and even a certain amount of it is listed in Concrete Floors and Moisture, which is another excellent book to have. These books both talk about permeance as far as concrete, obviously, and building materials. Know your permeance because it is going to adjust your drying times automatically. You don't have any choice to change permeance. So once you get the permeance factor of your material, you multiply that by the surface area and then the vapor pressure differential between sides A and B of the material. And that will get you your permeance of that material, or how fast the water is going to move through that material. It's easy enough to understand that when we're talking about something like carpet. Carpet's perms of 90, so water is going to pass through it very, very quickly, very easily. And of course, it only has to go from the fiber into the air, so it doesn't have much distance of travel. So that makes it what? The fastest drying material if it's kept in the facility while we're drying. A little slower than that, of course, is our drywall. Drywall typically has perms in the 50 or so range, depending on its thickness. And the concept is, though, when we put 2 layers of paint on top of drywall, we drop the perms all the way down to 10. That way, when you open up a wall, we're drying from the inside, which of course has what? A higher permeance factor, meaning we can dry the wall faster than if we're just drying from one side of the wall with the wall still sealed up. That's the difference. The paint becomes a vapor retarder on the outside, lowering your perms, slowing your drying times. Of course, right after that is wood. Typically, wood is going to be perms around 10 to 5 on our softwoods, 5 to 3 or 2 in our hardwoods. So that is again why what? Timber framing and hardwood floors take longer to dry than drywall. Plus, they also have a further distance of travel. We're getting thicker in our materials at the same time. Lastly, of course, is concrete. Now, concrete is typically 12 to 18 inches thick or even more. It has perms of less than 1. So you've got a long distance of travel and a very slow speed to get there, which means, of course, it's going to take quite a long period of time, typically 3 to 4 weeks to dry a concrete slab. Remember, permeance is one of the most important drying factors in timing of your drying project. The other is the distance of travel the water molecule has to go to. In other words, speed, permeance, distance of travel, and of course, speed times distance of travel gives you your estimated time of arrival. In this case, the estimated time of finished drying. Once again, thanks for learning with RTIlearning.com.